In this session, let us learn how to build a server storage for a direct attached storage. This will provide a complete information with a step-by-step approach to assemble a direct attached storage server.
Electrostatic discharge, ESD, precautions. This is very important information to you all. Please listen carefully before proceeding further. When handling any electronic components, devices, or any printed circuit boards, certain precautions need to be taken while handling them and during assembly. The warranty may be void if equipment is damaged by ESD. This is because a ESD of 20 volts can damage the components. The components does not go bad at first but tend to malfunction or may resist to function after some time. Basic precautions. Always carry electronic components in ESD bags. Assembly operations should be always carried in a ESD controlled area. Wear an anti-static wrist strap properly grounded when handling electronic components and equipments. Hold the host bus adapters by the corners or the metal shield. Avoid direct contact with any of the components and avoid contacts with clothes because the ground strap cannot dissipate static charges from fabrics. These are the components needed to build a direct attached storage server. The components needed are: server motherboard, CPU, RAM, 8 GB minimum, DDR3/4 based of motherboard support. Storage adapter, PCIe host bus adapter. Disks drives, SAS HDD, SATA HDD, SSD. A direct attached enclosure JBOD. SAS cables. Heavy duty power supply unit for motherboard and JBOD. Server cabinet, optional. Monitor, a LED display. Keyboard and mouse. Push to on switch with jumper wire for motherboard. MDF board as a base for the motherboard and the storage box if no cabinet is used. Miscellaneous, PCB rivets, adhesive tapes. This picture illustrates how a direct attached server components are connected. This is also a pictorial diagram of a serial attached SCSI topology. Motherboard rivet mount. The rivets are needed to mount the motherboard on a surface. Rivets help the motherboard to have an optimal gap between the base and the motherboard, avoids any metal contacts and provides an airflow passage gap under the motherboard. A server motherboard has 9 PCB mounting holes. Insert PCB rivets from bottom of motherboard until it clasps firmly. Ensure that the rivets do not fall from the motherboard. Rest the motherboard on a MDF board. Install the CPU. As a safety, CPU has notch on edges that matches with the CPU socket and can be installed only on one side. Place back the socket levers and lock them. Install the heatsink and fan unit on the CPU socket. Connect the fan wires to the motherboard CPU fan pins. Storage host bus adapter, HBA, installation. The storage HBA has PCIe X8 lanes. The notch on HBA should match with the notch on the motherboard's PCIe slot. Insert the HBA into a PCIe X8 socket on the motherboard. For more information, please also refer the HBA vendor's installation manual. Continuing the storage host bus adapter, HBA, installation. Gently push the HBA into the PCIe socket of the motherboard. Ensure that the HBA is firm on the motherboard. Please note that no extra pressure is exerted on the PCIe slot. This might tend to damage the slot and external components. Now, let us build a JBOD enclosure backplane. Remove the empty drive bays from the enclosure slots. Place the disks, SAS, SATA, SSD, onto the drive bays. Fasten the screws provided with the enclosure box. Ensure that the disks are firmly placed and no screw heads are projecting outwards. Continuing the JBOD enclosure backplane build. Insert the drive bays back into the enclosure backplane. Push the drive bays gently into the enclosure until the disks are connected into the backplane rear sockets. Secure the locks of the drive bays. You may lock the drive using the key provided. Let us connect a mini SAS cable to the HBA's connector. Connect one end of the mini SAS SFF8643 cable to the host bus adapter's X4 SAS port. The mini SAS cable connector has a latch on one edge, hence it can be inserted only in one way into the HBA's X4 port connector. Mini SAS cable connection to RAID on chip, ROC, controller if your motherboard has a ROC populated on it. Some server motherboards have RAID on chip controller. These are used as RAID on motherboard, ROMB. This design is more useful in internal DOS where the disks can be configured in RAID 0, RAID 1, RAID 5 etc. This provides a redundancy in the data. Continuing mini SAS cable connection to ROC. If you want to have RAID configurations, connect one end of the mini SAS SFF8643 cable to the motherboard's X4 port instead of host bus adapter's X4 SAS port. The mini SAS cable connector has a latch on one edge, hence it can be inserted only in one way into the HBA's X4 port connector. Let us see how a mini SAS cable is connection to JBOD enclosure backplane. This is also called as the connectivity from a server to a storage box. Connect the other ends of the mini SAS cable to the JBOD enclosure backplane 7-pin connector. The 7-pin connector has a latch on one edge, hence it can be inserted only in one way into the backplane 7-pin connector socket. RAM installation and power connections on the motherboard. Insert the RAM DIMM module into the DIMM slot 0 of the CPU 1. Push gently and secure the slot lock into the memory module's notch. For a server storage, a minimum of 8 GB RAM is needed per CPU. Connect the CPU's 8-pin connector onto the motherboard for 12V CPU power supply. Connect the 20-pin connector motherboard power supply. A power switch is a push to on or off switch needed for the motherboard for a user to switch on or off the server. Connect the power on/off switch into the motherboard's control panel header pins. Please refer the motherboard user guide for pin-related information. Now, let us see the various ports for LED display monitor, keyboard and mouse. Connect LED display's VGA connector to the motherboard's VGA port. Server motherboard have a minimal VGA capability. If you want a high-end display for GUI-intense operating systems, you are advised to install an external graphics adapter for smooth and high-end visual experience. Connect keyboard and mouse to the USB 2.0 ports. Connect the Ethernet port for LAN connectivity to the clients. Congratulations! We have built a complete direct attached storage server. Let us see the internals of Intel motherboard HW, Sandy Bridge EP platform. Intel processor codenamed as is Intel's 2011 Performance Mainstream Architecture Refresh Program. The CPUs shipped early in 2011 for both desktops and notebooks. The Sandy Bridge microarchitecture is the successor to Nehalem microarchitecture. Sandy Bridge is manufactured in the 32nm process, while Intel's subsequent generation Ivy Bridge. The motherboard uses two CPU sockets as shown in the diagram. A PCHC602 is used for storage connectivity. This is a good example of Intel motherboard HW with Sandy Bridge EP platform to start with. This is an internal block diagram of Haswell processor with Welsbig Processor Controller Hub, PCH. Haswell is the codename for a processor microarchitecture developed by Intel as the fourth-generation core successor to the Ivy Bridge microarchitecture. Features carried over from Ivy Bridge. New features are: Haswell featured a fully integrated voltage regulator, wider core up to fourth arithmetic logic unit, ALU, third address generation unit, AGU, second branch execution unit, BU, deeper buffers, higher cache bandwidth, improved front-end and memory controller, higher load/store bandwidth. New instruction set includes advanced vector extensions too. The instruction decode queue, which holds instructions after they have been decoded, is no longer statically partitioned between the two threads that each core can service. New sockets and chipsets were introduced. Intel X99, codenamed Welsbig, is a platform controller hub, PCH. The platform controller hub, PCH, is a family of Intel chipsets, introduced in 2008. It is the successor to the previous Intel hub architecture, which used a North Bridge and South Bridge in the platforms. The PCH controls certain data paths and support functions used in conjunction with Intel CPUs. These include clocking, the system clock, flexible display interface, FDI, and direct media interface, DMI, although FDI is only used when the chipset is required to support a processor with integrated graphics. The I/O functions are between the central hub and the CPU compared to the previous architecture. The North Bridge functions, the memory controller and PCIe lanes, were integrated into the CPU while the PCH took over the remaining functions in addition to the traditional roles of the South Bridge, which connects to the slower peripherals like storage controllers and other devices. This is AA Supermicro X10 DRHC, Intel C612, server motherboard. Key features: 1 dual socket R3, LGA 2011, supports Intel registered Xeon registered processor E5-2600, V4 or V3 family, QPI up to 9.6 GT/s. 2 Intel registered C612 chipset. 3 up to 2 TB-ECC3DS layer DIMM, up to DDR4 2400 MHz, 16x DIMM slots. 41x PCIe 3.0x16, 6x PCIe 3.0x8 slots. 5 Intel registered i350 dual port GBE LAN. 610x SATA 3, 6 Gbps, ports with Intel C612 controller, RAID 0, 1, 5, 10. 78x SAS 3, 12 Gbps, ports with Broadcom 3108. Controller, 2 GB cache, RAID 0, 1, 5, 6, 10, 50, 60. 8 integrated IPMI 2.0 and KVM with dedicated LAN. 9.5x USB 3.0 and 4x USB 2.0 ports. Assignments. What are the precautions that need to be taken before handling any electronic components? Explain in detail how ESD affects the electronic components. List out the components needed to build a multimedia workstation and a gaming PC. List out the differences between a server and a multimedia workstation. List out all the Intel motherboard platforms and the processors associated to it. List out merits and demerits of a laptop versus a desktop. List out the prominent components of a gaming desktop and a server. Perform a market survey and list out the materials needed to enclose the server components into a cabinet for an internal DOS.
This is the end of the session. For any queries or more information, please log in to www.sbkmake.com. Thank you.